Yay, we made it. This is our last video. This is section 6.2, same handout. Make estimates and predictions based on a quadratic model. And the first problem that we have here, a student believes that the data listed in that table suggests a quadratic relationship since the values of y increase and then decrease. Is this student correct? So do you see what they mean? That you've got the 0 has a 1, where the 10 has a 1. The 1 has a 2, and then symmetrically the 9 has a 2. And it keeps going through 3, 3, 7, 7, all the way to what looks like it could possibly be a vertex. Honestly, looking at it, it looks like it could be, right? But we can't quite tell just by looking at those numbers. So let's go ahead and graph it. Okay, so go ahead and do your y-axis up to 30, your x over to about 12 or so. Plot those points. You can try to smoothly connect the dots and let me know if you think it's a quadratic or not. Okay, so press pause, come back when you're ready. All right, so here is mine. So I plotted my points. What do you think? Does that look like it's a quadratic? At first it does, right? If you only looked at like the top half, but then you can see that you have these weird tails going on over here. This is not a quadratic, okay? What we actually have here is something you see a lot in statistics called the bell curve because it looks like a bell. Okay, so this is not a quadratic. All right, number 9. Let's see, what do we have here? Percentages of married people who reach major anniversaries are listed in the table. So we've got 5th through the 35th, and they jump to 50, and then the percent. And it says let P be the percent of married people who reach their anniversary, quadratic model. First thing that we're going to do is draw a scattergram. So just right on top of the scattergram, plot those points. So for example, I'm going to go to 5, and I'm going to guess what I think looks like about 82. I'm going to say somewhere around here. Okay, so go ahead and plot the rest of those points, and then come back when you're done with that. All right, so what do you think? Does it fit the data well? I think it does. Looks great. Yeah, it's pretty close. Next, what is the p-intercept and what does it mean in this situation? So hit pause, write down your answer. What do you think is the p-intercept and what does it mean in this situation? So the p-intercept is where it's crossing that p-axis, which looks to be at about 0.95. Now, does that make sense? It does not, because what that's saying is on their 0 anniversary, so the moment that they get married, only 95% of married people are married when they get married. That doesn't make any sense, right? So when things like this happen, it happens quite a bit because it's just an approximation. It's just a model that is a general good overall model, but every now and then the model breaks down. Okay, so when it just doesn't make sense, you just write model breakdown. All right. For C, what percent of married people reach their 20th anniversary? So take a look on your chart, go to the 20th anniversary, and go ahead and go up till you hit that parabola, and where do you think that is? Looks like somewhere around 43. I would take anything between 41 and 43 probably. Okay, it's about 43%. Next, what anniversary does exactly half of marriages reach? Okay, so half of marriages, so what percent is that? 50%. So let's go to the 50 and go all the way over to our model till we hit it, and then drop all the way down Where do you think that is? Like around 16, 17. About their 17th anniversary. And then finally, we have, does the part of the parabola that lies to the right of the vertex describe the situation well? And this is a very strange question. I think that what they're trying to get at is that this isn't quite a parabola. They've just shown you like half of a parabola, because we learned that the lowest point is that vertex. So if this were to continue back up, would that represent the situation well? So that would mean that as people kept getting further and further along in their anniversaries, suddenly, as these were going out, suddenly their percentages of staying married would be going up. That just doesn't make any sense, right? So no, it would start to go back up, which just doesn't make any sense at all. All right, so we have another one of these on the next page. Go ahead and give that one a try. Go ahead and do the scattergram and then try to answer all the questions. And this one gets a little bit tricky because we're so used to almost all the time they tell us since 2000. But in this one, look carefully, they say since 2005. Okay, so 2007 would be at 2, right? Okay, so go ahead and answer all the questions for this one. Press play when you're ready. So we have them plotted. Again, it looks like it's a good fit. Predict the sales in 2016. So what did you get for that? For 2016. So it's talking about what would those sales be? And it's going to be years since 2005. So how many years would that be if it's 2016? We're thinking at 11 years, right? So I'm going to go from 11 all the way up until I hit my model. And I would say somewhere around like 11 and a half. I would take anything between 11 and 12. Okay, that's a close one. Next, for part C, it says estimate in which years 5 million GM vehicles were sold. So 5 million. So it looks like it's here. Pretty close to that 1. So I would say that's 2006, right? And there was one other one. Let's keep going. 5, all the way till I hit it again. It's like at 8, so 8 years since 2005. So I think we're talking about the year 2013 there. All right, next, what is the S-intercept and what does it mean in this situation? So if you look at your graph, so it's 6, the dash is 7, anywhere between like 7.1 and 7.6 or 7 would be good. I'm just going to go with 0, 7.5, which would mean that 7.5 million vehicles were sold in 2005, since it's 0 years since 2005. And estimate the year when the sales were the least, and does that match what really happened? So let's look. Where does it look like it's the least? Maybe let's look at the graph first. I'm going to try to find the lowest point. Probably somewhere about here. I'm just going to round and say, how about like in 2010, because it's at the 5. So I would say 2010 based on the graph. But let me scroll up and look at my table again. Where was it the least? Let's see. Looks like the least was actually 2009. So again, it's a model, it's an approximation. So say 2010 based on the graph, but 2009 based on the table. That is it for this section. You'll see that there are some extra pages in your packet. If you didn't, go ahead and print it all off. This was an activity that we actually already did. Do you guys remember that? So that was the exponents. So this is just in here because the way that I used to teach the course was in a different order. So that's just a double up. You can have it though for extra practice. All right, we are done. That wraps up the videos. You are amazing, wonderful. Thank you so much. Have a great day.